All right, folks, let's go ahead and we'll start this lecture on the heart. So if you go to your outline, and we'll start kind of zipping through some of this with the heart and finish up this chapter pretty quickly, I hope, because it's not a real long chapter. So with your introduction, heart is essentially the pump for our cardiovascular system, and I'm going to disappear from your screen as we move into the meat and potatoes of this stuff. So the function of the heart, essentially to propel blood through the estimated 100,000 kilometers or kilometers of blood vessels. You've probably heard it said that if you strung all the blood vessels out end to end in your body, it would go around the entire planet 1.5 times. So that's about how much it would be. So you want to study the heart, become an expert with the heart. You would be studying cardiology and become a cardiologist if you wanted to pursue that as a career. So let's talk about the location and the projection of the heart based on what you're seeing on this picture right here. Heart essentially is a shallow cone-shaped organ about the size of your fist. So we say one fist is the size of our heart. If you put two fists together, so if we did this and kind of put the two fists together like this, we would say that is essentially the size of our brain. So our heart, one fist, our brain, two fists. Okay. It's about 12 centimeters long, 9 centimeters wide, 6 centimeters thick. So we don't have to worry about that in regards to numbers as far as what you have to know for me in regards to anything specific for that. Let me show you something real quickly here if we just go to this view. And if you look behind me on the whiteboard, and this is all experimental, so we're playing around with this a little bit. So on our whiteboard right here, if we look at this, I want to show you that this thing right here that you see is essentially non-existent. Okay, that only exists, you guys, in Hallmark cards and on Valentine's Day. All right, so really the heart is really more kind of referred to as a cone-shaped organ, so it's kind of more shaped that way. So that's really kind of a little more appropriately what the heart is actually shaped and looks like. So we'll erase that and we'll come back and use that whiteboard a little later. So let's go back to our notes here. We say our heart's located between our lungs, and the reference point there is referred to as the mediastinum, mediastinum, the mediastinum. And about 2/3 of the heart lies left of the midline. So if you see my cursor here, and I run it right down through the trachea here, and right down the midline there, you can see about 2/3 of it lies to the left of the midline. So you should know that fraction, about 2/3. The apex of the heart. So if we say it's kind of triangular shaped or a pyramidal shape, we say the apex of the heart is the lower pointed end down here, and then the base of the heart is the upper portion, the broader upper portion. So once again, if I bring my picture into here, I actually brought a model out with me from the classroom. And so if we do this real quick, I can show you here on this, the kind of the heart, the way the heart is actually shaped. Okay, and I'm kind of backwards on my screen. So the heart really kind of sits more kind of this way. All right, and so we say this is the apex down here, the pointed portion down there, and the broader portion on top here would be what we refer to as the base of the heart. Okay, so if you want to add in your notes a couple of things here, we like to say that the apex of the heart points to the left hip and the base points to the right shoulder. Okay, so put down the apex points to the left hip, the base points to the right shoulder. The heart has both an anterior surface and an inferior surface, and sometimes the inferior is referred to as the posterior surface because the heart doesn't sit straight up and down, it kind of sits at a tilt. All right. The right border faces the right lung, which sounds pretty obvious right here, okay? And the left border of the heart obviously then faces the left lung. Now let's talk about the pericardium, the actual tissues that surround the heart, okay? So we look at this, our pericardium here, and if I go to my other illustrations, if I can find them and pull them all up here, all right? Let's go to this one. Okay. Pericardium is a sac, and the sac essentially surrounds and protects the heart. That's what it's there for. And there's two major layers to the pericardium. All right. The first one, number one, the pericardium, the outer layer is what we call the fibrous layer right here. So the outer layer is known as the fibrous pericardium. essentially acts like a sac around the heart, keeps it from overstretching, all right, protects it, also kind of holds it to the actual mediastinum, the thoracic cavity, so it kind of attaches it. So you have the outer layer, which is the fibrous pericardium, and you have the deeper one right in here, which is known as the serous pericardium, S-E-R-O-U-S. There's two sublayers to the serous pericardium, though, all right? The first one, all right, letter A, is the outer, what's called the parietal layer right here, all right? Let me use my pencil here so we can kind of illustrate that. So the outer layer right here is the parietal pericardium, all right? And then we have a deeper layer inside right here. So the deeper one is known as the visceral pericardium down there. The visceral pericardium is continuous with this structure right here called the epicardium. So the visceral layer or epicardium, right, is the inner layer of the serous pericardium. Now between them there is a space right here, okay, and that is known as the pericardial space or the pericardial cavity right there, and it contains pericardial fluid. So it's a lubricating fluid that sits between the parietal layer and the visceral layer of the serous pericardium. And what happens is when the heart beats, that layer acts as a lubricating layer to prevent friction from the two layers so that they don't rub against each other every time the heart moves. Okay. So we'll clear all that out and let's go to the layers of the heart wall, and we'll look at this, kind of keep this picture up here. So there's three layers to the heart wall, and you're seeing these right here. The outer layer we refer to as the epicardium. So we said the visceral pericardium is known as the epicardium, so it's this layer right here. So there's the epicardium, epi again meaning above, so the outer or top layer is the epicardium. Okay. The thick middle layer, which is all this in pink or red in your picture right here, is the myocardium, which is essentially the muscular layer. Myo for muscle. Okay, so it's made up of cardiac muscle tissue. And then the inner layer right here in purple, once again, is the endocardium or the inner layer. And that endocardium is going to be continuous as blood leaves the heart and goes through all the blood vessels. So it would be the inner layer of all the blood vessels as well. Okay? So once again, really to recap that, the three layers of the heart wall, the outer one's the epicardium, middle one's the myocardium, and the inside one or the inner layer is the endocardium. Okay? Let's talk about circulation of blood. The heart is going to pump blood into two separate circuits when we look at it. So let's go back into this one right here. And let me show you this quick picture right there. And if I go to this and get that out of there, if I can do it. All right. Let's move to this one here. And if I can get rid of that, I will. So hold on with me for just a second. Okay, so let's continue on from there. Sorry about that little interruption. Okay, so with our circulation, we have two closed circuits that our heart is going to pump blood into. All right, number one is known as the systemic circulation. All right, number two then is known as the pulmonary circulation. So the left side of the heart acts as the systemic circulation, the pump for the systemic circulation. So what it does, it receives oxygenated blood from the lungs and then pumps the blood into the aorta. As you can see right here, there's the aorta, right? The largest artery in our body. It's going to subsequently branch into systemic arteries that carry blood to all the different organs in our body, with the exception of the alveoli of the lungs itself. Okay. In tissues, arteries are going to branch into arterioles, and then subsequently those branch into systemic capillaries, where the gas exchange takes place between oxygen and carbon dioxide, as well as the exchange of nutrients, waste, gases, and things like that. Then number four says capillaries are going to merge to deliver deoxygenated blood into systemic venules, V-E-N-U-L-E-S, and then they're going to merge to form larger vessels, which are the systemic veins, and that carries the blood back to the right atrium of the heart there. Okay, so if I bring this back up and we look at our whiteboard again one more time here, and I go to this, let's trace out kind of essentially how that works. And we mentioned this the other day. So As blood essentially leaves the heart, and we'll use our little generic heart, it's going to leave by way of arteries, which will then branch into arterioles, which branch into smaller vessels called capillaries, which is where our gas exchange takes place. As we head back to the heart, those vessels will be known as venules, all right, and those will become veins, which then deliver blood back to the heart, okay? So that's essentially the way the blood is delivered to our heart. Blood's taken away from our heart and brought back to our heart. So I'll erase that now so we can have a nice clean whiteboard here in a few minutes when we need it. All right. So that's essentially the circulation in that regard. Okay. What we want to do, all right, in just a minute, we're going to show you the whole circulation. We're going to draw it in a method that you'll be able to retrace and draw out yourself. So number 5, as we finish this up, says the right side of the heart then is the pump for the pulmonary circulation. It receives deoxygenated blood returning from the systemic circulation, pumps it into what's known as the pulmonary trunk, which you can see right here on this picture. That carries blood to the pulmonary capillaries, where that blood is going to become oxygenated there. All right. So what we want to do right now is we're going to take and actually draw out. You'll see on there it talks about used for drawing of generalized circulation. So let's take a second, and we're going to take a little bypass here and go to this picture. All right. And what I want to do is hopefully get this enlarged enough to where you can actually see this on the whiteboard. And if I can bring it a little bit closer, I will, without knocking everything over. And I'm going to draw this out for you, and you're going to need to be able to retrace this drawing or draw it back out. I'm not sure exactly how we're going to do that in an online version of a quiz or anything like that, but let me show you essentially kind of what this is going to consist of. Okay, so we're going to have to do this with the light out, hopefully, so you can see this a little bit better. All right, so we're going to talk about our circulation of blood here. So let's draw our heart. And again, remember, our heart is more of a cone-shaped structure, so we'll draw it like this. You're going to take up the majority of your page with this picture right here. All right, and we're going to label the 4 chambers of the heart. So right here we have our right atrium. And we know it's our right atrium because this person up here is looking at you, right? Hopefully you can see him smiling at you right there, okay? All right, so this is going to be our left atrium. We can abbreviate that one. Up here, we would have our right ventricle. So I'm going to have to squeeze that in here. V-E-N-T-R-I-C-L-E, right ventricle. And then down here, obviously, would be our left ventricle. So we're going to start with our blood flow, and we're going to start in the right atrium, just because that's where I choose to do so. So we'll start in the right atrium and say blood flows from the right atrium into the right ventricle. So we use arrows to denote all these, lots of arrows on here. From the right ventricle, the blood comes out and goes to these paired structures here, which we're going to label as our lungs, okay? Not very good looking lungs, but hey, it works as long as we know what they are, okay? So lots of arrows. All right, it's going to pick up oxygen at the lungs, all right, and take it back into the left atrium. From the left atrium, blood will flow into the left ventricle. From the left ventricle, the blood's going to come out, and it's going to deliver part of it up in here. So we're going to add some arms and hands and all that good stuff right here. And we're going to label this as the head. Erase that. Head, neck, and upper limbs. Head, neck, and upper limbs, right? There we go. And lots of arrows, like I said. Another branch of this is going to take the blood down this way and deliver it to the trunk, we'll put, and lower limbs. A lot easier when I can do this on a great big whiteboard, but we're trying to make it work here, so let's do it that way. Blood then is going to go from, once the blood is dropped off, oxygen is dropped off, we pick up the CO2 and the waste. We're going to bring blood back up into the right atrium. And from the head, neck, and upper limbs, we're going to do the same, bring blood back into the right atrium. here. Okay, so there's our circulation of our blood. As we said, we consult the right side of the heart, our pulmonary circulation, because it's going to leave the right ventricle, go to our lungs, right? And the left side from the left ventricle, we're going to call this a systemic circulation, because the blood's going to leave and take it out to the rest of our body. So now we have to label a few of these different blood vessels. So right here, taking blood away from the heart. We said the blood vessels that take blood away from our heart, since this one's going to the lungs, we call these the pulmonary arteries. Okay, and so the blood coming back to the heart comes back by the way of the pulmonary veins. So we have to label those. Okay, pulmonary arteries, pulmonary veins. Then this large vessel taking blood to the systemic circulation is known as the aorta. Parts of it is going to take blood to the upper portion of our body. The other half is going to take it below the diaphragm to the lower part. And then returning the blood back from the head, neck, and upper limbs, we have the large vessel called the superior vena cava. Some people say vena cava, whichever one you prefer. And then down here, this is obviously going to be our inferior vena cava, so we can just abbreviate that. Okay? So I would need you to be able to reproduce that drawing. I may ask you to do it for me on a video within a matter of a few seconds. So I would have you practice this. Make sure you know this and are able to draw this out rather quickly because it's a pretty simple drawing. I had my high school students for years learn this in a night and be able to draw it out the next day. So once you draw it out like 3 times, you've got it made. It's not too awful difficult. But that's essentially our circulation of blood, how it goes through our body and returns to our heart. There are a few little discrepancies here, some inaccuracies on a technical level, which we'll get into a little bit later. But for right now, that covers most of what you need to know. You will refer to this drawing multiple times when you go to answer questions on a quiz and or on a test. So this is a very valuable thing. This actual drawing here itself came from a physiology textbook for nurses. All right, Dr. Ward has a version in his atlas that's somewhat similar to this. It uses blocks and squares, but I kind of like this, so it'd be nice if you could reproduce this for me if I asked you to do that. All right, I'll turn my light back on, move my whiteboard out of the way, and let's return back to the lecture part of this. All right, so if I can return just back to our screen and get myself out of the picture here. All right. So let's talk about the chambers of the heart. All right, so we have 4 chambers in our heart that we just mentioned. So let me go to a different picture here on our illustration. I'll open it up this way. And this is real similar to what you see in the atlas when you look inside the chambers. Here, so this is the picture that kind of shows us the most valuable information right here. All right, on our as far as what we have available on our pictures here. All right. So, chambers of the heart. The 2 superior chambers, as we said, are the right and the left atria. Atrium is singular, so atria, A-T-R-I-A, is plural. Okay. Each one has an anterior appendage in the front of it, which is known as the auricle, A-U-R-C-L-E. And you can kind of see a little bit more up on this picture right here. There's an auricle up on there. And if I show you real quickly, on the heart model here, okay, let me do this and just real quickly hold this up for you. All right, you can see on the heart model here, okay, this is the auricle right here, atrial appendage, and essentially that auricle is in there for one purpose, and that's to hold more blood, be able to hold more blood into the heart. Okay, so there's the auricle there. There's one in the right atrium, and there's one in the left atrium as well. Okay, so those are our auricles. Move me back down here out of the picture a little bit. The 2 inferior chambers there are the right and the left ventricles. All right, V-E-N-T-R-I-C-L-E. Okay. Then number 3, as we just said when we did our drawing, the pulmonary pump consists of the right atrium and the right ventricle. All right, pumps deoxygenated blood toward the lungs, and then the systemic pump, which is made up of the left atrium and the left ventricle, takes that oxygenated blood and propels it to the rest of the body. Now, the surface of the heart has 3 major grooves on it, and if you look in your atlas, you can actually see those grooves listed. And if I go to page number, in your atlas, if you look on page number, he shows these to you. Basically on the pig heart is where you actually see them the best. All right, so let's look on 6.5. You can basically see this on 6.5 and 6.6. I think the easiest way for me to show this to you is going to be, once again, to kind of hold up this heart model and show you the heart model here as best I can. So when you look on the heart model here, always the hazard when you're using these models that never stay together. Okay, so our three major grooves. As we go around here, the back of the heart, you can see around here. All right, you can see there's a groove that separates the atria from the ventricles, and that groove right here is known as the coronary sulcus. And then right down the front side here, you can see a groove running down the front, and that groove right there is the anterior interventricular sulcus. And we have a similar groove on the back side. If I take my heart kind of off the stand here and do it this way, and you'll see there's also a groove on the back side running right down here, and that's the posterior interventricular sulcus. Okay, and normally you would get to see that if we did our heart dissection, which unfortunately I don't know that we're going to get to do given our current circumstances, so we'll miss out a little bit on that, but maybe we can actually pull it off where we can do one of those and let you watch it. Okay, so let's talk about each one of these chambers individually. Let's start here in the right atrium. So in the right atrium, it's going to receive deoxygenated blood from 3 different veins, and those 3 veins are as follows here. So let me get it so we can cue all these in. The first one, superior vena cava, and if you remember back to our drawing, the superior vena cava was one of those veins that brought blood back to the right atrium. Okay, the next one is the inferior vena cava, which you can see down here. That one actually brings the blood back into the right atrium as well. And then we have one more vessel that's going to drop blood into here, and it's called the coronary sinus. So right here is your coronary sinus, and that's going to drain the blood from the wall of the heart and empty it back into the right atrium. Now, the anterior right atrial wall has some muscular ridges in it, which are known as pectinate muscles, Pectinate, pectinate muscles. You don't see them on the picture here, but you can see them in the atlas and on the models, right? The interior of the heart has an interatrial septum. So we have a septum between the left and the right atrium called the interatrial septum. Doesn't show it on the picture here, but it's essentially what separates the right atrium from the left atrium. Interatrial, interatrial septum. And then in that septum, there's a depression, this little circle here, oval-shaped depression, and that is known as the fossa ovalis. We'll talk about what that is a little bit later. It's a leftover from a remnant of when we were in fetal development there. Okay. Now, blood from the right atrium is going to go into the right ventricle as it flows through, like we talked about in our drawing, and it's going to go through this valve right here, which is known as the tricuspid valve, or just simply the right atrioventricular valve. Sometimes we just abbreviate that, the right AV valve. But the right AV valve is known as the tricuspid. You have to remember that term, okay? So now we got blood into the right ventricle. So let's head down that way and let's look into the right ventricle and see what we got going on here. So the inner surface of the right ventricle has some ridges on it, and I'm going to show them to you here in the left ventricle because they're the same thing. Those ridges are what's known as trabeculae carneae. Trabeculae carneae. Carne in Spanish means meat. So these are very meaty, thick ridges in the ventricles. All right. Then you see these string-like structures here. That's what's next in your notes. These are called chordae tendineae. So these chordae tendineae and their associated papillary muscles, which they're attaching to down here, papillae, remember nipple-shaped projections. Okay, so the chordae tendineae and their associated papillary muscles here ensure that the cusps of the tricuspid valve right here, so here's our chordae tendineae here and our papillary muscles in the right ventricle. Make sure that the cusp of the tricuspid valve here, all right, allow the blood to flow into the right ventricle from the right atrium, but prevent backflow of blood into the right atrium. So once they close up and they make a seal so the blood stays down here in the right ventricle and doesn't backflow into the right atrium. Remember, that's the purpose of any valve, is to allow something to flow in one direction. So this valve allows blood to go from the atria into the ventricles, but prevents backflow back into the atrium. Okay. So from there, we have a large structure here between the right ventricle and the left ventricle, and that's the interventricular septum, the big septum between the two ventricles, separates the right and the left ventricle. Okay, the right ventricle pumps blood through the pulmonary valve, which you see right here. All right, from the pulmonary valve, it sends that blood into the pulmonary trunk right there, and then from there that's going to divide into the left and the right pulmonary arteries. So this is where it's a little bit different from our drawing. If you remember our drawing, we show blood leaving the right ventricle down here and going by way of the pulmonary arteries. So we kind of misled you a little bit in that, but at least you could think back and know where the blood flows. In the actual heart, that blood is pushed upward through the pulmonary trunk, which becomes the pulmonary arteries, okay? And has to go through the pulmonary valve to get there, all right, when we do that. All right, so next up here, once we go to the right ventricle, all right, we're going to have to go to our left atrium, all right? So now we're up in the left atrium. In the left atrium, number 12, all right, we have oxygenated blood returns from the lungs, and it returns that way by way of 4 pulmonary veins, and you can see a couple of them here on the left side, all right, a couple more there. All right, those 4 pulmonary veins are going to bring blood back into the left atrium, all right, and there's 2 pulmonary veins, 2 superior, all right, and 1 superior and 1 inferior from each lung, all right, that drain into that left atrium. Then blood in the left atrium is going to flow into the left ventricle through the bicuspid, or what's also known as the mitral valve, which is essentially our left atrioventricular valve, or the left AV valve. So we kind of have 4 different terms we could use for this. Bicuspid or mitral is a term for the left AV valve, or left atrioventricular valve. So make sure you're aware of that. And bicuspid and mitral are both used about the same. Okay, maybe mitral is a little bit more common, all right, when they're referred to that. So now we've taken blood from the left atrium, brought it down into the left ventricle. So in our outline, the left ventricle is going to be almost exactly like we saw with our right ventricle. So forms the apex of the heart. So most of the apex here is left ventricle. Inner surface has the trabeculae carnae, the muscular ridges. Also has the chordae tendineae, which, by the way, literally means heartstrings. Okay, so that's a nice, interesting thing to know, is the heartstrings. You can go search or Google your music lyrics over the years, and you'll see all kinds of songs about tugging at the strings of your heart. So we literally do have strings in our heart. So the chordae tendineae and their associated papillary muscles then are going to make sure that this bicuspid valve allows blood to flow from the atrium into the ventricle, but prevents backflow from the ventricles back into the left atrium. Okay. All right. Then the left ventricle is going to pump that blood up, and it goes back behind here, behind the pulmonary trunk, and you can see through the aortic valve, right? And it goes into the ascending aorta, and you can see the label right here. So the aorta is going to come up as the ascending aorta, right? The ascending aorta gives rise to the right and left coronary arteries, and those are going to be the blood supply to the wall of the heart itself. So right and left coronary arteries. And the ascending aorta then is going to become what's known as the arch of the aorta, as it makes a bend to the left here. Okay. So arch of the aorta is followed by the descending aorta down here, which has 2 parts to it. All right. Descending aorta above the diaphragm, we call it the thoracic aorta, and below the diaphragm, then it's going to be referred to as the abdominal aorta. And then branches of the aorta are going to deliver blood through the systemic circulation, which we'll cover in the next chapter. It says during fetal life, the temporary ductus arteriosus, DUC, DUS, arteriosus, Arterious. It's going to shunt blood from the pulmonary trunk into the aorta. It acts as a bypass. It'll take blood and it'll go from the pulmonary trunk directly to the aorta here. Because you'll remember, once we're during fetal development, we're in the womb, we're in water, so our lungs aren't even inflated. We don't use our own lungs. We're getting oxygen from mom's blood, so we can bypass the whole pulmonary circulation portion to the lungs until we come out of the womb and take our first breath. All right. After that happens, after we're born and we no longer use that bypass system, this essentially kind of dries up a little bit, or this vessel closes up and it leaves behind a remnant or a afterpiece, which is now referred to as the ligamentum arteriosum. Okay, and the ligamentum arteriosum only shows up on one of our models, and I'll go over that when we do the model review a little bit later on. Okay, talk about what's in the atlas. Okay, next up, myocardial thickness. If you look at this, and you can see it on the picture, but if you just think about it, it really just makes sense this way, okay? And if you go back to your drawing and reproduce that drawing we went over, walls of the atria typically are going to be relatively thin, while the walls of the ventricles are going to be thicker, because the atria only has to pump the blood from there into the ventricles, which is a very short distance. And if you think about the right ventricle and the left ventricle, and you go back to your drawing, the right ventricle only has to pump the blood to the lungs, which are right next to our heart on each side. The left ventricle, on the other hand, has to pump the blood out to the rest of our body. So it says in your outline, the wall of the left ventricle is much thicker, as you can see here, than the wall of the right ventricle, because it has a greater distance to pump that blood, so it's got to be a bigger, stronger muscle. Next in your outline, we have the fibrous skeleton of the heart. So if we go to the fibrous skeleton, and we look at this view right here from up above, this view essentially here, let me take this down about to here, kind of shrink this down a little bit like that. All right. And I'm going to shrink that just a little tiny bit more here if I can. All right. Maybe I can't. I'm not going to be able to do that. It doesn't look like. So we'll just leave that with that right there. Okay. So if we take the top half, we cut a transverse plane through the heart like this. And if you look down on top of the heart here, you can actually see from the, looking from above here on that transverse view, here's the anterior portion, there's the posterior portion right there. Let me get myself out of the picture here. All right, you'll be able to see the fibrous skeleton of the heart. And what's this referring to? Around these valves, since there's so much pressure around these valves that open and close, you'll see that they're a little bit thicker here, all right, around the where the valves actually form here, and that's what's known as the fibrous skeleton. All right, the fibrous rings are essentially the right atrioventricular ring, left atrioventricular ring there, the pulmonary fibrous ring here, and the aortic. So from this view, if you look in your atlas on 612, all right, you will see in the atlas, you'll see a picture almost exactly like this, right? And the picture that you're seeing like this is kind of upside down in the atlas, but you can see that model. The top actually pops off of this model, and I will do a video, make sure you can see where all this is at. This is the pulmonary valve here, all right, with a fibrous ring. There's the aortic valve there with a fibrous ring. Remember that aortic valve came behind the pulmonary valve when we looked at it, all right? And this is our right AV fibrous ring, which is our tricuspid valve, and then we have our bicuspid or mitral valve over on this side. So make sure you know that picture in that model on 612 in the atlas, because that could show up very easily on the lab exam. Several times we've had that model out with that picture. Okay, so as we talk about the flow through these valves, all right, and kind of what they look like here. When you look at this picture right here, it kind of shows how those work. The four valves prevent backflow of blood in the heart, made up of dense connective tissue, and they're covered with endocardium. All right. There are two atrioventricular valves, or two AV valves, right? Once again, number one, they're the tricuspid valve between the right atrium and the right ventricle. And then we have the bicuspid or mitral valve between the left atrium and the left ventricle. the chordae tendineae then here and their papillary muscles, which they attach to. Make sure the cusps of the AV valves allow blood to flow from the atria into the ventricles, but prevent backflow of blood. Once these close up like this, okay, now there can be no backflow of blood going this direction right here. Okay. And then it says number 4, there are 2 semilunar valves, and I don't know that I brought up the picture of the semilunar valves. No, I didn't, right? So the 2 semilunar valves, let me go ahead and I will bring that picture up so you can actually see the difference in the semilunar valves. Okay, so there's a picture of kind of what our semilunar valves look like. We have 2 semilunar valves. Each one has 3 semilunar cusps, so like half moons, all right? So there's what they actually look like off a cadaver, all right? First of all, we have the pulmonary valve located between the pulmonary trunk and the right ventricle. All right, if we go back to our picture that we had up earlier, you can actually see those valves right there. Okay, so our pulmonary valve right here, right? And then next up, number 2 would be the aortic valve, which you see below it here, okay, going underneath it, between the aorta and the left ventricle. And again, the cusp of those semilunar valves basically allow blood to be ejected from the ventricles, but prevent backflow of blood back into the heart. Now, in your outline, under letter I on the coronary circulation, it says refer to Dr. Ward's atlas. So if you have your atlas and you were open to 612 in your atlas, it might help to actually open to that as I go through the following pictures here, because we want to talk about, we're going to use Dr. Ward's view of this, all right, to talk about what we're going to see for each of these blood vessels here. All right, so I'll kind of just use the cursor and go over the ones that you're responsible to know. So as we go to the anterior view, which on page 612 in the atlas is, I want you to go to these bottom 4 pictures. It's the left upper one, says anterior. All right, coming right down the center here, all right, this large blood vessel right here is the anterior interventricular artery. Right there, anterior interventricular artery, sometimes called the anterior descending artery. Right alongside of it, as you'll see right there, right alongside of it is the great cardiac vein coming right here. So there's a great cardiac vein with the different branches coming out of that. So those are those 2 structures that you need to know right there. Pretty simple from the front, okay? When we look at the next view, so we're going to go from the front, we'll go straight to the posterior view on the back side. When you look at this, so the picture is right below it on 612. Okay, a couple different things we need to know. Right here on top, let's talk about this in the coronary sulcus. There's our great cardiac vein right there in the coronary sulcus, right there. Right next to it on the other side, the smaller one, is the small cardiac vein. Right there. The great cardiac vein is going to empty right into here, and that's where the coronary sinus is, where the blood's going to empty back into our right atrium from there. Okay? And then coming right down the middle, right here, okay, we have the posterior interventricular artery coming right there, also known as the posterior descending artery. So interventricular is probably easier to know. Anterior interventricular on the front, posterior interventricular on the back side here. And right alongside of it, right here, this vessel is the middle cardiac vein coming right there, sometimes called the posterior descending vein. So a lot of these change over the years, the terms they're going to use for these different things here. All right. Up here, the red vessel on the right side here, okay, that's going to be our right coronary artery right here. So make sure you're aware of that. There's your right coronary artery there. And then over on this side, for some reason, the only thing that's labeled here is the posterior cardiac vein that you can see right there. Okay. So make sure to know those and label them in your atlas, the ones that aren't labeled from there. Let's go to this view here. And I believe from this view, we're seeing the left side of the heart here. Okay, so we should be seeing the left side. So if we go in your outline, we're going to jump to letter D, so the left side of the heart. Okay, left marginal artery. Remember, if you're going to write a paper for somebody, you set the margins of your paper, so the margin's the side. So going down right now, we have our left marginal artery, and right alongside of it is our left marginal vein, okay? And the left marginal artery and vein are not labeled in your atlas, so make sure and label those. Put those in there. The left marginal artery is sometimes referred to also as the obtuse artery. I don't really use that term a lot, but that's the only thing he labels in the atlas on this side right here is the obtuse artery. But I think it's easier for you to remember left marginal artery and left marginal vein. Those are coming off. The left marginal veins comes off the great cardiac vein right there. And then right alongside of it here is your left coronary artery, also known as the circumflex artery. And that's the only thing he labels once again in the atlas is the circumflex, but I think it's easier for you to know that is the left coronary artery right there. And then if we go to the right side here, last picture we have to cover would be the right side of the heart here. And you can see coming down the right side here is the right marginal artery and the right marginal vein right alongside there. So right marginal artery and vein. All right. And the the only one you need to know here's our right coronary artery coming off there again. And I'm not going to hold you responsible for this one here, all right? But this right here is known as the anterior cardiac vein. But a lot of textbooks don't even really cover that, all right? So right next to our right coronary artery, you can see the small cardiac vein right next to that once again, as we looked at it before. So those are the vessels you really need to know as we go into that right there with those different parts. So let's talk about the cardiac conduction system. And what we're really referring to here is what controls the beating of our heart. So our heart beats by way of an electrical circuit, right? Just kind of the way blood vessel or muscles work as well, right? So it comes off of our nervous system. It's partially dependent on that and partially works independently of that. So for cardiac conduction system, it says during embryonic development, there's a small portion, about 1% of cardiac muscle fibers that become what we call autorhythmic cells. That's what goes in your blank there. And it allows those cells to perform two different functions. Number one, they act as a pacemaker, which sets the rhythm for contraction of the entire heart. And it helps to form what's known as the conduction system. That's what goes in your blank, to conduct action potentials throughout the myocardium. And the components of the conduction system are what you see right here. So there's 5 of them. I believe it's labeled A, B, C, D, and E in your outline, but it's 1, 2, 3, 4, and 5 here. So the first one is the sinoatrial node, or what's called the SA node, and that is found up here in the right atrium of the heart. So make sure and make note of that. And that initiates every single heartbeat. It comes from the SA node. Because of that, the SA node is referred to as the heart's natural pacemaker. So when somebody has a problem with the SA node, they're going to have to get an artificial pacemaker put in to take over the job of the SA node. Okay, that's going to conduct the impulse here to number 2, or letter B in your outline, which is the atrioventricular node. So it's found in the wall between the right atrium and ventricle. Okay, or the AV node, simply referred to that. From there, it's going to go right here to number 3, which is referred to as the AV bundle. Stands for atrioventricular bundle, more commonly referred to as the bundle of His, because that's the doctor who came up with that label. All right, it doesn't mean that females don't have one. All right, so they have a bundle of His as well. From there, it's going to branch as it goes down the interventricular septum into right and left branches known as the right and left bundle branches. They're going to go down to the apex of the heart. One going to come up the right ventricle wall, lateral wall. One's going to come up the left lateral ventricle wall, and those are known as the Purkinje fibers. So those are the 5 components, right, of the cardiac conduction system, sometimes referred to as the nodal system, N-O-D-A-L, because of these nodes here. All right. So I included a picture of that in your outline so you know that. The nervous system and some hormones can increase or decrease the pace of contraction of the heart. It says, but the nervous system doesn't initiate the contractions. It's done by this nodal or conduction system initiates the contractions themselves. So if we wanted to take a view of this and see what the electrical conduction system of the heart looks like, we'd be looking at an EKG. And you will look at these in great detail when you get into physiology and study them in a lot more detail than what we're going to cover here. So an electrocardiogram, right? Or an EKG or an ECG, either term is appropriate, is essentially a recording of what goes on electrically in the heart, right? So during each cardiac cycle, you're going to have some waves recorded. So those waves would include the P wave, the QRS wave, sometimes called the QRS complex, right? And a T wave. These are all recorded. And I want you kind of just to know the basics of these, so once you get into physiology, you'll at least have some of the basic outlines of what's going on here. So real quickly, just to kind of recap each one of these and tell you what's going on. So the P wave represents depolarization of the atria, or just atrial depolarization. Okay, so what that means is the atria are contracting. Okay, atrial depolarization or contraction of the atria. All right. The QRS wave, what's going on there, is depolarization of the ventricles, or ventricular contraction. And then finally the T wave right here is repolarization of the ventricles. So they're relaxing right here. Okay, so if you look at this, it's like, something's missing. Okay, so we have atrial depolarization, we have ventricular depolarization, we have atrial or ventricular repolarization. So where's repolarization of the atria happening at? Okay, and you make a little note there and include this. Okay, atrial repolarization is hidden by the QRS wave. So that's where it occurs. Make a note of that in your notes right there, okay? Atrial repolarization is hidden by the QRS wave. Okay? So what's an EKG really telling us? Well, basically abnormalities, okay, with the cardiac conduction system, all right, can be detected, right? Things like arrhythmias, right? Or a myocardial infarction, okay? An MI, myocardial infarction, INFARCTION, which is just our medical term for a heart attack. Okay? And it can include one that just occurred recently, all right, present time, or even one in the past. And it can also detect heart cells that have been damaged due to ischemia, ISCHEMIA. One spelling one more time, ISCHEMIA, and that means a decrease in blood flow, all right? So if we don't get enough blood flow to the heart cells, they're going to die. Okay? So let's talk about now what happens during the cardiac cycle, or what happens during one complete beat of the heart. Okay, so let's talk about cardiac conduction cycle, what happens in one complete heartbeat. So the events of a single heartbeat, okay, that's from the first contraction to when it contracts a second time. So the cardiac cycle comprises all the events associated with one heartbeat. In a normal cycle, the two atria will contract at the same time while the ventricles relax, and vice versa, all right? So a couple of terms. First one, systole, S-Y-S-T-O-L-E. Systole is the contraction phase of chamber of the heart, whereas diastole, D-I-A-S-T-O-L-E, is the relaxation phase of a heart chamber. So when you take somebody's blood pressure, for instance, average adult blood pressure should be a reading somewhere around 120 over 80. The 120 represents the systolic pressure, which is higher because the heart's contracting, and the 80 should represent the diastolic pressure, or the lower pressure, which occurs when the heart is relaxing. Okay, so let's talk about the three phases of the cardiac cycle. And actually our textbook here probably has the best explanation, the simplest version of this that I've actually seen, so it makes it pretty easy to remember. So let's talk about number one, the relaxation phase. So a couple things to write down here. In the relaxation phase, all four chambers are relaxed, which means the pressure is low. So you can just draw an arrow down for low pressure. The semilunar valves are closed. So we mean the aortic valve and the pulmonary valves are closed. Okay. The AV valves are open. So the tricuspid and the bicuspid valves are open. So blood is flowing from the atria into the ventricles. And actually, you need to know 75% of blood leaves the atria and goes into the ventricles during this phase. So then we go into the second phase. Now we have atrial systole. And if you remember, systole meant contraction. So I like to compare this to if you're washing your own car, and hopefully everybody's washed their own car before and not just driven through Prime Shine or whatever they call it now, all right? So if you're washing your car and you have a big sponge in a bucket full of soapy water, and you lift the sponge out of the water and just hold it there, you'll notice that most of the water leaves the sponge, all right? However, it's not all completely out of the sponge. To get the rest of the water out of the sponge, you have to squeeze it, right? So during atrial systole, we're essentially going to squeeze the remainder of that 25% of the blood out of the atria into the ventricles. So in your outline, just put remaining 25% of blood leaves the atria as they contract. So you're wringing out that sponge and getting rid of the rest of the water, right? And that's essentially what the atria are doing. They're just kind of squeezing the rest of the blood out of the atria into the ventricles. And that's all we really have going on in atrial systole. Then we go to the third phase, which is ventricular systole. So the blood pushes against the AV valves as this fills up, closing them, okay? And for just a brief instant, all 4 valves are going to be closed. I mean, it's not even a second, just a brief instant. So the pressure is increasing in the ventricles, forcing the semilunar valves to open. So now your pulmonary valve and your aortic valve are going to open up, and blood leaves the ventricles. And then once it does that, we start all over again. And essentially this happens approximately 75 times in a minute. So the time for one cycle basically breaks down into about 0.8 seconds. And you need to know that number, 0.8 seconds. All right, let's finish this up then, talking about our heart sounds. All right, so the term for listening to the heart sounds is known as auscultation. It's usually used with a device called a stethoscope, and it's going to reveal 2 major sounds that occur in the heart. The first one is described as lub, L-U-B-B, and the second one would be dup, D-U-P-P. So let me put us back in the middle of the screen here and enlarge this, and that way if I need to write on my board, I can go ahead and do that. So let me erase this, and we can bring it a little bit closer here and erase some things here from our drawing. Okay, so I reach up there. Okay, so our 2 heart sounds would consist of lub, L-U-B-B, okay, and dup, D-U-P-P. Those are our 2 heart sounds that occur right there. All right. And what those are, okay, those are heard due to turbulence as blood flows through the closing of the AV valves and the semilunar valves, respectively. So the lub is the closing of the AV valves. The dup is the closing of the semilunar valves that occurs, okay? A couple of things to note here and write down in your outline, right? The first sound is longer and louder, okay? So longer and louder for the lub. And the second sound, the dup, is shorter and sharper. So your heartbeat doesn't really sound like boom, 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 boom. It's more of a lub, dup, lub, dup, lub, dup, lub, dup. Okay? And obviously when the doctor listens to your heart, they move the stethoscope around because different areas in your heart can allow you to detect the sounds differently from one place to the other. Okay, a couple other things with exercise and the heart itself. So let's go back to our picture here. All right, exercise in the heart muscle. You know, obviously, the exercise is good for our heart. So aerobic exercise improves our cardiovascular system all the way around, as well as the respiratory system. Prolonged training can do things like make your maximum cardiac output increased, reduce your blood pressure, help to dissolve small blood clots, improve our function of our lungs, and just a psychological and mental, emotional state of well-being occurs with that as well. A couple other terms we need to write down and make sure that you're aware of. So I guess I should pull this back in here one more time, and we'll use our board once more. Tachycardia. Okay, so tachycardia is a heart rate greater than 100 beats per minute. Right, so tachycardia for a short period of time is not severe, but the heart cannot sustain a long period of tachycardia without going into cardiac arrest, obviously. The other term is bradycardia, which we say is a heart rate of less than 60 beats per minute. All right, so a low resting heart rate is obviously better than a high resting heart rate, and people who are endurance athletes like marathon runners, cyclists, and things like that may have a lower resting heart rate than the average person, but less than 60 beats per minute is pretty rare, and in some instances bradycardia may actually be indicative of things like protein deficiencies and things like that. Okay. One or two other things to talk about. If you draw a teeter-totter on here real quickly, let's put one on there and just list a couple of things as we close this out here. So with the teeter-totter, we can have problems with valve. So we'll put valve disorders. Okay, so there's a few different things that can happen with our heart valves that are not normal. So a couple of those would include, first of all, leaky valves. So it's no different than if your sink has a leak or the faucet in your kitchen has a leak. A little bit of a leak we can live with, not worry too much about, but if it's leaking a whole lot, then we get really concerned about it. So with a leaky valve or an incompetent valve, often that leads to the need to replace that valve. And what that valve is often used to replace or is replaced by will either be a synthetic valve, artificial valve, or still used even today would be a pig valve. So they can actually take a valve from a pig and replace it with into a human heart. Okay, and that still occurs once in a while. The other thing that could cause a problem with the valves is what's known as stenosis. So valvular stenosis. What happens is those valves get very stiff and hard, and instead of being able to open and close really easily, it's very hard because those valves are stiff and they don't like to close and open very easily right there. Okay, so those tend to create some distinct sounds when they're auscultated or listened to, and the doctors can usually pick up those things pretty easily. Most times, if they're in the situation where they're bad enough to need surgical intervention in those cases. All right. So I think that concludes most of what we need to know in regards to the heart. I'll be posting some videos to go along with the lecture here in the next day or two to accompany this and take you through some of the stuff with the heart models. Make sure and look at Dr. Ward's atlas. As far as the histology part of the heart, it's very simple on 613 in the atlas. On the left-hand picture, you're going to see pictures of the wall of the heart, and you can see the epicardium, the myocardium, and the endocardium listed there. And then actually in the center of it, you'll see blood in the ventricle. So if you take that and think of like the right ventricle in the heart, you see the wall in the upper portion there. So if, later I may show pull out and make a video just describing a little bit about that slide later on. So I may do that as an addendum to this if we feel like we run into a situation where you need to do that. So finish your outline, cover everything we talked about here, look at the models in the atlas, study those as well as the histology, and I'll see you when we do the blood vessels, which will be the next recording that we do. All right, great. Thank you.